Okay, like this. Let's say you have 3 buckets and 1, 2, 3, that's a name. And there's a pebble underneath one of the buckets, and then there's a lot of swap. So clearly the Bessie, play the game, and Elsie gonna guess, right? Bessie always know where the pebble is anytime Bessie swap the buckets. And after each round, after each swap, Elsie gonna guess where the pebble is in the number-wise, which bucket. If correct, then Elsie at that round get 1 point. And you can imagine there's a lot of rounds. At the end, you get our total points. The question asking you, given the swap and guesses, but not the initial pebble location, please determine the highest possible score Elsie could have earned. All right. Let's look at one example here so for you to understand. So here's there are only three buckets. So here represented by 1, 2, 3. So the first line of the input contains integer n. Given the number of swaps, there are 3 swaps. Each of the next n lines, so next 3 lines, describe a step of the game and contains the 3 integers, a, b, and g. The first 2 integers indicating the shells a and b, in our example, 2 of the buckets, were swapped by Bessie. And then Elsie guessed the shell G after the swap was made. All 3 of these integers are either 1, 2, 3. So you only have 3 buckets, and A is not equals B. Before we run example, just by looking at, like I said, what is the step to solving USACO problems? Number 1, of course, define the problem statement. We're pretty much going to do that. One part is you're going to decide the algorithm in terms of time complexity to finish this one. So this one you can see that ends are rather small. You see the ends just less than 100. And also for the given variables, you see the potential, the possible, the buckets is only 3. You only have 3 buckets to be swapped around. There could be n rounds of swaps. So if you get this, you can have a fairly sense that, I mean, the linear time definitely works regardless, because n's are rather small. Even n squared, they're gonna work. I mean, it really depends on the time limit set. But generally, if it's a linear you can deliver, that definitely will work. So that will be part of your analysis while you develop the problem statement. Now, use a case. The first number going to tell you there are 3 swaps. So let's go through. So the first swap is bucket 1 and bucket 2 guess swap. And the third number 1 is that after swap, Elsie guessed that the pebble is in bucket 1. Bessie could be right if the starting pebble, is at bucket 2. Because when this bucket at index 2 swap with the bucket at index 1, and after that, this pebble coming to here at index 1 bucket, and if Elsie guess, okay, that's a 1, then Elsie get 1 point. So that will be it. And continue to the second one. 3 and 2 buckets, the 2 buckets at index 2 and index 3 gonna swap. I mean, for this example, if let's say starting pebble is at the bucket 2, and after the first swap at bucket 1, then swap bucket 2, bucket 3 doesn't make any difference in terms of the position of the pebble. It's still at the bucket 1. And you see here, if Elsie still guess pebble as at index 1 bucket, and then he got a 1 more point again. And the third swap, you see that is buckets at index 1 and index 3 swap. And clearly the pebble now gonna move its positions to the index 3 buckets, right? And LC now still gets, okay, the pebble still at index 1 bucket, actually is not, then she gets 0 points. So that will be it. That will be the questions. And the question asking you, please output the maximum number of points Elsie could have earned. So how to do that? You should have a little sense that since this one is pretty much category to brute force, to traverse. So you can think about it this way. Is possible that you can have a variable to track the position of the pebble at the end of each round of swap. And given that variable and compare with the guess from Elsie, if same at 1 point, if not, no points. However, the challenge is Elsie did not know where the pebble start, right? Because the game make a little fancy. Elsie does not know. That's why there's a maximum possible number of points or a minimum number of points Elsie could have earned, because Elsie do not know actual position of the pebble at the very start. So that's why another traversal, you're gonna traverse that. Assume the pebble starting at the bucket 1, or bucket 2, or bucket 3. And for each one of situations, you're tracking the location of the pebble over the next 3 rounds. And just figure out which one gonna deliver the maximum number of points. That will be it, right? And we have the luxury to do that, which is literally brute force. There's no algorithm actually behind, because all the numbers are very small, 100, and you're dealing with 3 buckets. I mean, yeah, right? That will be it. So given that, let me try to have a notepad. So for this question, the concepts is just iterations. And the method, I'm trying to describe the method we're trying to use is try to guess each initial possible position of the pebble and track the position during the end swap. The position of the pebble. At end of each round, compare the position you maintained with guess. If correct, add 1 point. If non-correct, you add 0. So, and then after that, return the maximum points. Because you have three cases, right? Pebble initial at the bucket 1, or bucket 2, or bucket 3. So since starting position different, so during the traversal, the position, suppose the position, your assumption on that position gonna also move along based on swap, right? So based on that, you can record, you can add up and figure out for which case gonna deliver the maximum number of points. So that will be the algorithm. That will be it. So I wanted using the first questions to really show using the template to deliver that. First of all, now let me double check any questions about the method we are using. I understand it would be tough. I assume I might be wrong. If so, please try to resolve it your offline time. because this is very tedious. I don't really want to spend a lot of time to just trying to understand the problem. But like I said, I want to quickly use a user case to align with you on the method. So then any question in the coding session is going to be your homework. But for this homework, but starting from today's sessions, I want you literally to submit it to USACO, the analysis mode. Under analysis mode, I want to check your code against with the user cases, and see how many user cases you can pass. With that being said, if no questions on the method we are using, how about we taking the first questions as a vehicle to see how to submit the answers, and by using the template. So then you don't have a surprise when you are trying to do it as your homework. All right, so that will be the context. Now let's deliver the code. Like I said, first of all, okay, so that was the header. We're gonna literally do that to let you see it. The public. First of all, guys, see that. Look at the question, kind of aligns that. What is the name of the file? So your code is gonna read the file called shell.in. That's input file. Your output file has to be with the name exactly shell out. And then, so then when you submit it, it can look at the name file shelled and checking the results and checking different user cases. So that's why for your class name, you want to name also exactly called shell. It's kind of funny that USACO actually using the class name where the first letter is lowercase, but mostly our routine is the first letter has to be uppercase. But now, since this is a shell, why don't you also name exactly identical as a shell? That's your class name. And then you're gonna have a main method. Like I said, we have templates, right? Let's just copy our templates, which is here. I already copied the class, so I just need to copy the end content. Okay, here, right? And you're gonna have a main method. And under the main method, you're gonna have a scan in, you're gonna have output. So that's a template, all right? So let's try to fill in with our algorithm. And then at the end, we're gonna submit it. So under this main method, you have a object name called in, which is scanner objects, and it taking the file. You see new scanner, new file, which is just, don't worry about that part. Just understand what does it do. That's constructor, right? But input is, and read the file name called problem. But this one, the file name is called shell. So just replace the problem to be shell, right? And then before you close the file, right? If you close it, you cannot read it anymore. So, so now you want to read this stuff, for example, as this example, into two things. Sometimes you don't have to record it because you can just read it while you are dealing with it, while you're processing it. And after you read the last digits, last numbers, and pretty much you already get your answers. So this is pretty much on the fly, right? You can just do that on the fly versus you have to record everything because your algorithm would not be that simple so that you can do that on the fly. But for instead, you had to record everything into a data structure and then you can dealing with that later. Mostly, there's not a penalty, mostly, but doing that because literally that's just O of n, space complexity. So it should be okay, but there's some situation where the end is very intimidating. And also you can literally do that on the fly, so you don't have to record it. You just literally use a variable to get a signed number that read and do that and feed in your algorithm and process it. So for this one, let's say we are not ready to do that on the fly. You want to record 121, 321, 131. Of course, we understand the physical meaning for each one of them, but you're going to think about how you're going to record the 3 lines, right? So what you can think of is, number one, I might want to use in 2D array. Second, I might want to use an array list. Which one is better? Clearly, you might lean towards the array, 2D array, because the size you already know. I mean, the size exactly, right? Every line has 3 numbers. Any line has 3 numbers. So you can just go ahead with 2D array, because array is always fast to get the number versus array list. Even though array list is also implemented by array under the hood. But for this case, I mean, just simple enough, you can just creating a 2D array to deliver that. But first of all, you have the first number to deal with, 3. The 3 is telling you how many lines of the numbers, which is very helpful. So remember, when you're trying to traverse all these lines for that for loop, you're gonna understand, how many lines. So that's why I'm gonna decide about the first number, which is 3, which is gonna be helpful. So you can record that number to n by using int called next int. So here, next int parenthesis, that's a method underneath the int, which is literally read the next number, which is gonna be integer. So clearly this is integer. So you got that 3 and assigned to the variable you declare as n. N physical meaning is how many lines. Since already you have the n here, to save the time, don't put the comment here, but you better do that. And then you're gonna record that 3 lines. So like I said, we are more prefer the 2D array. So you're gonna have a 2D array. Let's say you're using the GIMS and creating a 2D array. Clearly the first bracket is gonna tell you how many rows, second bracket is gonna tell you how many columns. Clearly there's gonna be n rows, right? What is the size of the column? It's gonna be 3, all right? With that, you're gonna record, you're gonna read all the numbers and put it into the GIMS, where it's your kind of buffer before you apply your algorithm to finish the questions. And then this one gonna just use the for loop. The for loop gonna starting from 1 and looping n times, less or equal than n. You can start from 0 and less than n, whichever. And I++. So this is a kind of counter, and do that for n times because you have n lines, right? And then you just need to assign GIMS. You are looking at the ith row. I'm sorry, this one you had to go from 0. The reason is because the I, also the physical meaning of I is not just about the counting for how many times you count for the total n, but also the I gonna serve as the rows number in this 2D arrays. That's why you want to start with 0. And you're gonna assign the readings from input to that 2D array. That's why GIMS I at the column 0, they're gonna give you whatever number there you read. Int next, int next int. And it gives at index I and column 1, again int next int. And again gives ith row and index 2 because the size of column 3, that's why 0, 1, 2. And again int next int. That'll be it. And so when I equals 0, you're gonna read a 1, 2, 1 and assign to 0, 0, 0, 1, 0, 2, and so on and so forth. The first row, the first row, second row, and third row. That'll be it. After that, pretty much you copy down the input into a 2D array. And to start from there, well, you can close it. Int close, which is gonna close off the file. The reading's done. And then you're gonna attach your logic here. The logic here, as we just discussed, we need traverse 2 things. Number one, of course, going to traverse these swaps, right? Procedures and how to swap, and has been assigned here. Also, there's a guess number you're going to check against. That's the first part. The second part is you're going to traverse the initial position of the pebble. Like I said, the LC does not the initial position. That's why there's a possibility of maximum and minimum. So that's the second traversal you're gonna put in here. So clearly we want to first to traverse the possible initial position of the pebble, right? And clearly you're gonna have a for loop and an int I. You can use in the same I because the I, its a life scope is within the for loop. That's why you can use in the same I as a variable, and you start from 1, right? And I just less or equal than 3, and I plus plus. That will be it, right? Because the physical meaning of the I is what? Is the initial bucket number, or initial inverted, what is that number? Shell, initial shell number. Could be 1, could be 2, could be 3, because the limitation here is only 3 possible shell. That's one traversal. And then before you writing down the second for loop, basically you're going to traverse, this is a metric here, right? You're going to think about what variable. I mean, the idea here is why you move into this second for loop to practicing the procedure of a swap. You have to apply the restrictions and comparisons. So you have to maintain the results at each round to a variable. You want to maintain it. Clearly, you don't want to declare the variable within the inner for loop because the life scope is just within the inner for loop, which is going to be really bad. So that's why it's okay that if you do not know what to declare, that's okay. Just go ahead and write the inner for loop. And at the end, go back because you figure out, hey, I need to maintain something, and after here. And when you're coding more, and clearly in your mind, you already know there's a physical variable you want to maintain here. So you can put something as int temp. Of course, you have to give your comment. So the temp gonna count the point the LC earned in that round. During the swaps, during the rounds of swaps, several rounds of swaps, or in rounds of swaps, right? That would be better, right? That would be the first variable. That's called temp. So, and also, the other thing, don't forget, is with that initial position, let's say 1, every round, you also have to know what is the position. What is the position of that pebble? Based on, if we assume the pebble is at bucket 1, when it swap 1, 2, 3, 2, 1, 3, at each end, what is the position of the pebble? So you're gonna have a second variable. Second variable, you can say in the position, POS. How to initialize position? Clearly gonna be I, right? Because you're starting at I equals 1. The physical meaning of I is the starting position of the pebble. Of course, right now the position of the pebble is I. So physical meaning, you're gonna put down in your comment here is track. The position variable gonna track the position of a pebble at the end each round, right? Now it's gonna look right. And one more thing, like that's what I'm saying is, if you do not do that, that will be also fine, because at a point you're gonna do that. You're gonna have a results, right? The result will be the answer you're gonna return. Guess what? Every round, I mean, I'm talking the outer for loop round, for each starting positions for the pebble, you're gonna have a different temp at the very end. So that's why you're gonna maintain the maximum one by the results. So at the end, you're gonna return the result. We're gonna talk about this stuff That's why you're going to have a variable outside the outer for loop. You're going to have a variable called results, waiting there to capture whatever the temp you can get in that given round, right? Now I think you're pretty much ready for jumping in the inner for loop. The inner for loop is what? Is you're going to traversal this 2D arrays. Traversal this 2D arrays actually only cares about 1D array, because in that 1D arrays, you have arrays with 3 numbers. So that's why for this for loop, you can have int j. You had to use a different name. You cannot use an I anymore, because I is still alive within this outer for loop. If you have int I again, then you're going to declare a variable with exactly the same name with the same overlapping left scope. You're going to have trouble. So you're going to use a different name j. So j going to starting from where? 0. And j going to less than gims length and j++. Of course, you need to understand the physical meaning of the j. The j now stands for which row in that 2D array you're talking about. So if j equals 0, you're talking about the 0th row, 1 to 1, so on and so forth. That's why j has less than gims length, which is which is 3. So index 0, index 1, index 2. That's fine. And under that is you can just copy down the numbers, because every row has 3 numbers. So why not just read it? That's the first bucket number, and this is second bucket number of that traversal of the swap, and J1. And also the third number is what? Is a guess from LC, right? Int guess equals gims and J and 2, right? And then you're gonna have a case discussions. So there are gonna be how many cases here? If you look at the user case given us, that there's a one case that is one of the buckets, 2 buckets contain the pebble. The pebble is, you assume the pebble is in that bucket named by I, right? Because you're starting with I equals 1, and then this 1 swap with the 2. So 1 or 2 contains the pebble, right? That's one situation. The second situation is the 2 buckets does not contain the pebble at all. So let's say you're starting the pebble at position 1, then you swap bucket 2, bucket 3, I mean, it doesn't change anything. So that's why, based on the case discussion, you're gonna think how you're gonna maintain the position and a temp. Remember what's the physical meaning for position and temp. At end of each round, you're gonna label the position. What is the pebble positions? That will be, you're gonna maintain at the end of each inner for loop. So here, let's write case 1. Case 1 is a one of N1 or N2 contains pebble. So if so, your if check, your if condition check is if N1 equals position or N2 equals position, correct? Like I said, if N1, N2 are the bucket numbers, let's say one of them, it has to be, right? One of the cases, one of them is a bucket where you can find a pebble underneath, right? That's if N1 is, if it is N1 or if it is N2. If so, and in the statement, you're gonna maintain what? You're gonna maintain the position, right? Because if one contains a pebble after swap, the pebble gonna swap to the other bucket, right? If you assume the pebble starting at the bucket 2 after swap, the pebble gonna move on to the other, which is 1. So this one, you're gonna maintain the position. This one, you're gonna use in what we just learned in a lecture. You're gonna check whether or not N1 equals a position. If N1 is the one contain the pebble after swap, then position gonna be N2. If N1 is not position that contains the pebble after swap, they're gonna go to N1, right? Of course, you can write if else, that's a 4 lines, but you can just shrink into 1 line. We'll talk a very detailed level on what is this, so I don't want to spend time again. So with that, you update the positions. And remember, after that, you had to what? You had to compare the position with the gas. If the gas is same as the position, then LC has 1 point. How to maintain the points? You have variable temp. So that's why you had to maintain 2 variable here to capture the transversal, the temporary results from the transversal. So here's, before you do that, you can argue that there's a second case, right? Case 2, none of N1 or N2 contains pebble. Well, guys, if so, you do not need to do anything on that position, right? Because it's not relevant. The position contained the pebble is not involved in that given round of swap. So in the case 2, actually you don't need to do anything. So, but whichever case 1 or case 2, you have to check against with the gas, right? So that's why after the if it is a case 1, you're gonna run this if or statements. If not, it just moves down to here because regardless, you have to maintain the temp. So here is if gas, so let me give the comment. Update temp accordingly. So here is if check, if gas is same as a position, right? If else you get correctly, and then 1, and then your temp plus, right? Added by 1. So let it run and finish this inner for loop. And at the end, you're pretty much gonna have the temp already be maintained. And you do not know whether or not you need to update the temp as a result, because result gonna record the maximum so far, the points that also can earn. So you just update the result as using math maximum results and temp. So max parentheses 2 variables underneath the math, which is static method, of course, is trying to get a larger number among the 2 variables. That's a math maximum method. And with that, you update to the results. And then you get it, right? That is the result you want to return. But anyway, the algorithm based on this, I think is super clear right now. This is a very fundamental question. It's bronze problem 1, basically warm up. And if you can making sure the user case runs through well, I don't think you're gonna have surprise with it. That will be the coding.